Hey there, Mind Institute. This video is for Delisha and Nigel. Rather than trying to take the time to really write down the idea for this lesson plan, since it's really a visual and online lesson by nature of being in ST Math, I thought I might as well videotape it and then be able to share it with you online so you could get a more sense of what I actually plan to do for this lesson. So the goal for this lesson is that students will be able to determine whether, students will be able to use the Pythagorean Theorem to find the length of a missing leg of a right triangle and find the length of a missing hypotenuse with a right triangle, which is a really important standard for 7th grade math, and something that I think conceptually students really have trouble understanding. I think I have a way to do this in 5 levels that can get students from a pretty simple starting point to the place where they can at least they can intuit the relationship between the different sides of a right triangle and be able to meet that final objective of being able to find the length of a missing side or a missing hypotenuse given that relationship. So there are 5 levels. I'm not sure if you can see the level here, but each one's going to have a different set of objectives, and we start with a really simple starting point, which is that students need to be able to understand what a right triangle is or isn't. And so they need to know, coming into this lesson based on a previous game, that a right triangle is a triangle with a right angle in it. And so level 1 is students will be able to determine whether a triangle is a right triangle just by looking at it, and then they're going to see a relationship that we're basically going to show them. So it's going to be a series of triangles. They won't have this right angle in it. And they need to say basically thumbs up, thumbs down, is this a right triangle or not? When it is, they'll say thumbs up, it's a right triangle. Then the program will say it is a right triangle, and then it's going to show them this relationship of, hey, if we take one leg and square it and make the other leg and square it, and then it'll visually show them, we can put them together, it'll cut it up, put them back together, it makes the hypotenuse squared. And then when they get to non-examples, like this triangle, which is an equilateral, and they say, no, it's not a right triangle, they'll get the ding, the penguin will cross the road, and then it'll try to show them, okay, if you take one leg and square it, and combine it with another leg and square it, and try to put them together, it doesn't match, like creates an uneven square. So, I don't know, sad face, penguin walks off, whatever, but they're seeing visually a representation of this. So they're just seeing this relationship based on their intuition of, is this a right triangle or is this not? Look what happens when it is a right triangle. Look what happens when it's not a right triangle. So that's the first stage of this 5-level lesson. Level 2 is then they start to get triangles that are a little harder to tell whether they're a right triangle. And obviously you wouldn't start with this, so you don't show them that angle. But they get a triangle like this and they need to determine, is it a right triangle? And so here's where they get to do more exploration. You find some way to let them explore with the idea of, okay, what if I build a square that connects that leg, build a square that connects that leg, and then the students have some way to actually test and try to put them together. So that would be part of the gaming here, is they're actually building both of the squares here, and then trying to reconstruct it to see whether it fits together to create a square of the third side. And then they're able to say, yes, it is a right triangle, based on whether it matches that relationship or not. So in a non-example, I'll create a non-example real quick. If they get a triangle like this, which looks not too different than the one I just showed, they try to construct, okay, so the relationship I saw in level 1 says that I should be able to square the two sides, and if I put them together, it'll make a third square. But if I take the third square for this side, it doesn't quite match up when I put those pieces together, and so I know it's not a right triangle. So rather than them just being able to tell whether it's a right triangle by looking at the angles, they need to actually test it using the relationship they saw in level 1. So in level 2, they start testing it, and they deepen their understanding of that relationship. All still for the purpose of saying, is this a right triangle or not? So by level 3, they should be pretty comfortable with the idea of this relationship, that if you take a side and square it, a side and square it, and put them together, it makes the longest side squared. Without necessarily having vocabulary for it, that's one leg squared. The sum of one leg squared plus the other leg squared is the equals the hypotenuse squared, or a squared plus b squared equals c squared. They might not have the language for it based on this point in the game. Level 3 is students to be able to identify the area of c squared using a squared and b squared, or students will be able to identify the area of a squared using b squared and c squared. And what that basically means is now, unlike level 1 and level 2, we're going to tell them, this is a right triangle, this is a right triangle. Now you need to be able to, as a student, to tell me something else, which is, what is the length, or what is the area of this missing square? So they're looking at, for example, I think you can see that first example. They have some way to figure out, okay, this is 16, either it shows it visually or there's a number. This is 9, maybe it shows it visually, or maybe there's a number. And they need to figure out what this missing area is, and they should be able to do that because they understand the relationship, and they say 25. Same here, maybe this is 169, maybe this is 144, and they're able to put those together and say, oh, this must be then 25. So still understand the relationship as this is the sum of these two squares, this is the sum of these two squares, to figure out the area of those missing squares. So we start in level 3 with the place of, we're telling you it's a right triangle, we're already giving you the squares of the legs, or the squares of the hypotenuse and a leg, and you're just telling me the area of the other square. So that's kind of a scaffolded version of the Pythagorean theorem. Level 4 becomes a little bit more complicated because now you give them the same information just like I did last time. Like maybe you tell them, I think you can see this, 16 and 9, I'm telling you it's a right triangle. But rather than asking them what's the area of the square connected to the hypotenuse, you're saying, what's the length of the hypotenuse? And they say, oh, well, last time I was able to say in level 3 that this was 25, and I know since this is a square, c must be 5. So it's using that relationship with one extra step to say, okay, now I need to find the square root of 25 to know that the hypotenuse is 5. In the same way, let's say we have an example here of I'm running out of Pythagorean triples, but let's say this is 25 and this is 169. They need to find not the area of B, but the length of B in the triangle. Well, last level they were able to say that this is 144, because that's the missing square. And so they're able to tell you in the game, in some way, that B equals 12. Because that means the missing length of the triangle is 12. In level 5, the only thing that's different now is you've taken that visual prompting, or that visual support, away. And so rather than actually having the square, and the square for a right triangle, you say, here's a right triangle, here's one leg, here's another leg, find the missing leg. And they should be able to say, okay, I know that 3 squared plus 4 squared should equal c squared, and be able to say, okay, c squared then must be 25 when I add 9 and 16, which means c must be 5. And so it's the same as level 4, except now there's no visual scaffolds, instead of doing it without any visually scaffolding. So if I look at the next example, again, I know that this is 5, I'm looking here, I know that this squared plus this squared must equal this squared. This squared is 25, this squared is 169. If I subtract them, this must be 144, which means B must be 12. And so by the end of level 5, they're able to take a right triangle with 2 legs and find the hypotenuse, or a leg and a hypotenuse and find the length of the missing side. Should be done in ways that is pretty carefully scaffolded, so you shouldn't lose students along the way. The big problem I anticipate here is doing this with a certain number of combinations that will still be accessible. So right now I've only been able to use 3, 4, 5s and 5, 12, 13s. Those would be patterns that students would pick up on, so you would need to find different Pythagorean triples that you could use comfortably, and you might run out. So that's something I'd anticipate having to work around. But other than that, that's my vision of how in 5 levels of this game you could get students from a place where they knew nothing more than what a right triangle is and isn't, to a place where they can actually tell you the length based on this relationship that they've discovered in this lesson. It's a rough idea, but I hope it gives you a vision of how this might be able to work for this really important 7th grade standard. Thanks.